In this video, we'll be talking about geometry notation and understand how to use them. In geometry, there are ways to read and write symbols. A few vocabulary terms and notations here. So we have a segment. For instance, a segment AB can be drawn as a part of a line that has two endpoints where A and B are the endpoints of the straight part of a line that has endpoints. So it starts at A, ends at B. We can read it BA. Segment is a part of a line that has endpoints, or we can measure and actually have a length. A line has this two arrows on the side. That represents a straight figure that extends endlessly in both directions. So let's say if I was to draw a line, I would put two arrows showing this endless directions in both ways, and then I have to have E and F points on the line, showing that this line goes through EF, I can read it backwards, FE, and it's endless in both directions. Lines don't have a certain measure. We can't measure them. Segments can be part of a line, so we can measure this part between E and F. That would be a segment. But the whole line going through EF is endless in both directions. Symbol for angle. Angle BAC. Angle is the amount of turn between two intersecting lines at a common point. So I draw two lines, let's say. This common point is the middle letter in the angle, always. B will be on one side and C will be on the other. The angle is the amount of turn, in other words, this opening between these two segments, BA and AC, intersecting. So BAC is the angle created at the opening where A is called vertex and the amount of opening or the turn between the two intersecting lines or segments is called angle. When you see a little m, that's the exact measure of angle KLM. Angle measure is the size. So when we see this little m, that's the actual size of the opening between two intersecting lines. So let's say I draw two lines or segments, and I have this common point, which is the middle letter L. On one of the segments, I put K, L, and then on the other I have to put M. So this particular measure, let's say since it's an obtuse, give it a number, 120 degrees. So this opening is 120 degrees, so that is the measure of the angle KLM. We would write it like this. The measure of angle KLM is 120 degrees. So the angle measure is the actual size of the opening between the two intersecting lines or segments. The symbol congruent, it's like equal sign and it has a little wavy line up top. So the congruent is like equal. Congruent objects are identical or have the same shape and size. So let's say if I have a triangle, another triangle congruent to it would be the same exact shape and size. I can have congruent segments. So let's say this segment is maybe 1 inch. And then I draw another segment and it has to be 1 inch. Congruent objects are identical and they have the same exact shape and size. Or I can have maybe a parallelogram, and if I have another one congruent to it, it has to be exact same shape and size. That's congruent. Symbol for parallel is like the double L inside the word parallel. Parallel lines are always the same distance apart and never meet. So parallel lines or segments are two lines that are the same exact distance apart and they never ever intersect or meet. To write parallel, let's say I have the line L and the line M. I can say that line L is parallel to the line M. So line L, parallel symbol, line M. Lines can also be labeled with one lowercase letter. Symbol for perpendicular is like upside down capital T. That is perpendicular, which means two lines that intersect each other at 90 degrees. Or right angle is perpendicular. So when I have a right angle and I have this little symbol for perpendicular in between, let's give it a name. I can say angle ABC is 90 degrees, where AB is perpendicular to BC. AB segment, perpendicular BC segment, they create an intersection of 90 degrees. So this vocabulary and other symbols can be used for different representation and problem solving. So let's just see a few examples. How to read the parts of the problem, interpret, and how to find missing information. So in the directions we have for each problem, label on the image the given parts and then answer the question. So I have little m, that means measure of angle DBE. B has to be in the middle. B is the intersection of this lines. So on one side I have to have D, in the middle B, E. To find that angle, I need to find D, go to B, and across to E. That is the opening right here of 50 degrees exactly. Angle DBE, so this angle of 50 degrees, is congruent, means same exact measure, as angle CBA. So let's find this CBA. It means that they're both 50 degrees. CBA is this opening right here, coming from C to B to A. We follow the segments, and that is the same exact measure, congruent, so I can label it 50 degrees. Another part of information, I have that the measure of angle CBF is 90. So I go from CBF, and that is 90. CBF being 90, that goes CBF, and that's 90 degrees. So now what we have to notice is that the angle right here is 50 and it's inside that 90 degrees. So the question is, what is the measure, how many degrees is the angle FBA? So from F to B to A. From F to B to A is this opening right here. And this is the question, how many degrees would that be? So if I look at the 90-degree angle, 50 degrees is taken by the angle CBA. So how many degrees do I need to complete this 90? 50 plus 40 equals 90, or we can say this angle 90 degrees and the angle 50. 90 minus 50 will be the question, which is 40. So angle FBA is the angle right here of 40 degrees. And if we look at these two angles, 40 plus 50 will be 90. 40 and 50 are complementary. AB is parallel to CD. So let's find this information. AB is parallel to CD. So we have those two parallel lines. Next, the measure of AGE is 125 degrees. So let's find it. AGE, here is the angle. The measure is 125 degrees. Another piece of information, angle EGH, so EGH, it's a straight angle. EGH is a straight line, 180 degrees. What is the measure of angle AGH? Let's find it. AGH is right here. And that is the question. So if I look at the straight line, 125 is the angle AGE or EGA. The angle next to it or adjacent to it is supplementary. Supplementary angles add up to 180 degrees. So to find this angle, we need to have 180 minus 125. $55 degrees. So the two angles that add up to 180 degrees are called supplementary. Knowing one angle, we subtract 180 minus 125, and that is 55. So what is the angle AGH? That is it's 55 degrees. Let's see what other questions we have. Angle AGH is congruent to EGB. EGB, where is EGB? Here, EGB. I'm going to use the double arc showing that they're congruent. So I have the statement right here saying that AGH, which is 55 degrees, is congruent to EGB. That means that they both have to be 55 degrees. Another statement I have is that EGB is congruent to CHF. Where is CHF? Let's find CHF. If they're congruent, I'm going to use that same double arch and color it the same color. So if those two are congruent, it means that they both have to be 55 degrees as well. So what is the measure? In other words, how many degrees? Angle CHF. CHF is 55 degrees. Two triangles are congruent. So triangle HIJ is congruent to triangle KLM. KLM. The two triangles are congruent if they're the same exact size. That means that all the segments are the same exact size, all the angles are the same exact size. So if I look at this piece of information, measure of angle HIJ, HI has to be the middle and then J. So HIJ, the I is the middle letter, so that is the opening where we need to see 72 degrees. The measure of angle IJH, so J being the middle letter, I need to go from I to J to H. IJH is 33 degrees. Different measure, I can have two arcs for 33 degrees. What is the measure of KLM? So KLM corresponds to the same angle in the first triangle, and it's going to be 72 degrees. L being in the middle, I had to go from K to L to M, so those two are both 72 degrees. They correspond to each other as congruent triangles. Congruent means same exact shape, same exact size. So segments and angles will be the same measure. What is the measure of LMK? LMK, so I have to go from L to M to K. That would be this angle right here, which corresponds to 33 degrees. Corresponding angles will be the same measure. So this will be 33 degrees as well. And what is the measure? And we have a missing angle. In other words, the angle that we don't know. Here's when we are going to use the property. The sum of the angles in the triangle equals 180 degrees. So to find the missing angle, what we need to do is subtract 180, the full triangle, minus the 72, and minus the 33. Or we can add 72 plus 33 and then subtract. In this triangle, the sum of the angles inside the triangle is 180. So to find that missing angle, we need to take 180, subtract 72, subtract 33. So 180 minus 72 minus 33. $75 degrees. To double check and make sure that we have it all calculated correctly, we have 72 plus 33 plus 75 equals 180 degrees. So the sum of the angles in the triangle equals 180 degrees. Let's see another example here. The measure of angle ABD is 180 degrees. So that's a straight line. ABD, straight segment. Measure of DBE, so the middle letter being B, I go from D to B to E. So DBE is this marked angle right here, 65 degrees. What is the measure of angle ABE? So B being in the middle, I have to go from A to B to E. ABE. Right here is my question. What property I use? I use supplementary angles. I have a straight line, two angles adjacent to each other on a straight line would add up to 180 degrees. So if I have 180 degrees minus 65, That will be the measure of my missing angle. (115°). Two angles side by side, lined up on a straight line, must add up to 180°. 115 plus 65 is 180. So my measure of angle ABE is 115. Angle ABE is congruent to CBD. So ABE is congruent to CBD. So CBD. This part of information right here tells me that the two angles have to be the exact same measure. So if this one is 115, this one is 115. They're called vertical angles. So if the question is asking what is the measure, it means how many degrees is angle CBD, we say 115. CD is perpendicular to AB. It means we have a 90-degree intersection. Let's find this piece of information here. So segment CD is perpendicular with AB. So these two segments create 90-degree intersections. CB and AB create a perpendicular intersection. So each angle here, 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 and here are going to be 90 degrees. So we have a perpendicular intersection that is 90 degree. Angle CEF is 52. Let's find that one. So CEF. CEF. That's the angle right here. From C to E to F. That's the opening right here. Is 52 degrees. Let's color code it. 52. What is the measure of angle FEB? Let's see. FEB. That's the angle right here. How to find that angle is what we need to notice that both angles, the question and the 52, are inside the 90-degree intersection. Okay, so that means that they're complementary. If one angle inside that 90-degree intersection is 52 degrees, the missing angle will be 90 minus 52. So we have this 90-degree intersection. 90 minus 52 will be the missing angle. So 38 degrees. 38 plus 52 is that 90-degree intersection. Okay, 38 degrees. If angle FEB is congruent to CG, let's find those. FEB is congruent to CEG. Congruent means they have the same exact measure. Let's make them the same color. They're both 38. What is the measure of angle GEA? Let's find that one. GEA. GEA and 38 are inside that 90-degree perpendicular intersection. 38 and our question mark now are complementary. To find the missing angle, we have 90 minus 38, which is 52. 38 and 52 together is 90. So using that complementary relationship, we can figure out that the angle GEA is 52 degrees. Check that out. Let's see the last problem. We have the angle EDC 28 degrees. So D is in the middle. Let's go from E to D to C. EDC. Here's the opening, and that is 28 degrees. Let's mark that right here. 28 degrees. EDC is congruent, in other words, same measure, with BCD. Let's find BCD. BCD is right here. Same measure, same color, same number, 28 degrees. Measure of ABC right here is 2 times BCD. Well, BCD being 28, 2 times 28 will be 56 degrees. What is the measure? So this one, 56 here. What is the measure of ABC? ABC is 56 degrees. What is EDC? So let's say EDC, 28 degrees, plus BCD, which is 28 degrees, and plus ABC, 56 degrees, together. So that would be 28 plus 28 plus 56. So the sum of all the angles, 28 plus 28 plus 56 equals 112. Using the given information, always label it. Make sure we use the properties of angle to find the missing information. Color coding always helps.